will say, it will ask you, is this helpful? So you can give it feedback. Another example here, Instagram. You can hide specific ads, but then it will ask you, okay, why don't you want to see this ad? What are the reasons behind it? Because it wants to understand why the ad is not relevant. And another example here, you see in Apple's Music, you see a love or dislike button. Both are easily accessible, they're quite prominent, and with that you can easily give some feedback back. Okay, so I would recommend going through the cards yourself at home and maybe discuss these with your peers. Now, if you want to know more, you want to learn more, and especially when you're pursuing some certification, I would advise you to also go to the learning paths at aka.ms/learn artificial intelligence. I've already opened up a browser tab with this, so let me just show you. Here we are. It will redirect you to this page. Get started with artificial intelligence on Azure. It's 27 minutes long, and it's a learning path, only one module, and it will actually also just guide you introductory through all the modules. And just an introduction to AI, understand machine learning, and these topics, right, which we already discussed. Anomaly detection, computer vision, natural language processing, conversational AI, and responsible AI. So again, if you want to know a little bit more and pursuing this certification, would definitely recommend going through these. So in this module, we covered the following concepts. We looked at what is artificial intelligence, what are some of the common artificial intelligence workloads, right? I talked about the violence detection, spelling checker, and numerous other things. And we've taken a look at artificial intelligence inside Azure. And in the second part of this module, we took a look at the challenges and risks with AI. Remember the bias. And we went through these 6 principles of responsible AI. And with that, let's get started with module 2. In this module, we'll be looking at machine learning. And we'll start, of course, by just an introduction to machine learning. And we'll look at these 3 types of algorithms, which is regression, classification, and clustering. And after that, we'll take a look at the Azure machine learning, what it is, and we'll take a look at the designer and automated machine learning, which we call AutoML. And well, I'll just demo that and I'll show you around in the portal, and we'll train a model in the designer, and we'll train a model using the automated machine learning. But first, just what is machine learning? And the goal here again is not to teach you linear algebra. It's just to help you gain an intuition on how machine learning works. So, what is machine learning? Machine learning is creating predictive models by finding relationships in data. Now, suppose I'm a botanist. I'm actually not a botanist, but the example is kind of funny. Suppose I'm a botanist and I just collect flowers. And each of these flowers, they have features such as the measurement of petals or stem or any other kind of details, color, you name it. Now I can provide a label, right, for these flowers. So I'm doing this, and you can see here I provided some labels. So on top left you can see 2 flowers, and I labeled those Bellus perennis, and the top right I named them Rosa multiflora. Now this sample data I can now process using an algorithm, and I can combine this together, and this algorithm now is going to find the relationships between the features and the labels. And after it has done this, I can now use this algorithm to predict new flowers. So in this case, I get a new flower, and my algorithm will predict then that it's probably a Bellus perennis. Really simple basics of machine learning. No math yet. Okay, so let's start with the first type of algorithms, which is regression. And regression is the most common technique, actually, where you want to predict a numeric value, like a price, sales total, or, well, you name it. And for this example, we're going to look at bike rentals. So before we can even train an algorithm, I need some data. So here it is. I have the temperature and the amount of rentals. It's in Fahrenheit, the temperature, so it's not in an oven. And you can see that at 56 degrees, I rented out 150 bicycles. And at the bottom of the chart, you can see that at 80 degrees, I rented out 154 bicycles. So already just looking at the data, it seems that when the temperature go up, my bike rentals might go up as well. So the thing I'm trying to predict here is the Y, is the bike rentals, and we're calling this Y, and the feature is the temperature, and I'm calling this X. Now, I'm not going to put this entire data set into a model because I want to test it as well. So what I'm going to do is split it up. Splitting it up in a training set and a validation set. I'm going to use the training set to train a model, and I'm going to use the validation set to validate the model. Now, in a real life example, because this is only a few rows, so in a real life example, it would be more data. I would, probably my validation set would be about 20 to 30% of my data. Now, so I have splitted my data, and let's plot it. I'm plotting the temperature on the horizontal axis and the bike rentals on the vertical axis. And here you can already see that there appears to be some kind of relationship. And I could even, plot a line through this, right? Because I'm trying to find some kind of function. So, plotting a line to it, and there is you can see the trend, and there's a couple of things that are interesting, because the point where the line intersects the vertical axis is around 35, and the slope of the line, well, it looks to be around, for every 1 increase in temperature, it looks to go up for about 1.5 bike rentals, right? Looks about right. So I have 35 as a baseline, and the slope is 1.5. Now, I can create a function out of this, and that would be this function. So this is all the math, folks. Don't be scared. So this is actually my algorithm already, right? Because the function over the temperature, and I can use that. So 35 plus 1.5 times the temperature will be my bike rentals. So let's test it, right? Because now I have my function, and we can test it with the validation data that we held back. And that is not called, those predictions that I'm going to make are not called Y, but they're going to called Y hat. So they have a little hat on top of it. And you can see here that for a temperature of 54 degrees, my actual bike rentals were 114, and my predicted bike rentals were 116. So there's a little bit of difference. And now you can see how well the model predicts by measuring the difference between the predicted values and the actual values that we know to be true. And this tells us the amount of error in the model. And there are various ways to calculate this error and generate some common metrics that we can use to evaluate a regression model. Now, if I plot again, I plot the predictions here on the graph, and indeed you can see that there is a little bit of error because they're not perfect. But again, perfection doesn't really exist. And and this is just this error. Okay, that is a really basic example of regression. And regression is another form of supervised machine learning. And supervised machine learning is when you have data that has a known label value. So in the case of the regression, I knew the amount of bike rentals already. I had that data. And in this case, for classification, we're going to look at diabetes. And I already have some data here with outcome variables. And after classification, we'll take a look at unsupervised machine learning. So for now, we have some data, including some features and a label. And the label here is the Y, whether a person has diabetes or not. And the features are some medical measurements like weight, height, blood pressure, and so on. Now, the label here is 1 or 0. So a 0 means not having diabetes, and a 1 means having diabetes. And the algorithm we're going to use will predict a number between 1 and 0. So it is a probability. And we'll take a cutoff value of 0.5 to determine whether a person has or does not have diabetes. But first, let's do the same as with regression. We're going to split the data up, into a training set and a validation set, training set to train our algorithm, and a validation set to validate the algorithm. We're also going to plot these values on a line. Horizontal axis, we've plotted the features, and the vertical axis, we plotted the Y, the outcome variable, or whether a person does or does not have diabetes. And again, like I said, we're taking this cutoff value of 0.5. We're plotting a line through the values, same as that we did with the regression, with the linear regression, but this time we're not putting a straight line to it. It's a logistic function. Okay, so we have that. Now let's look at our validation set. Again, we have a little bit of validation set, and we plot again the values on this line. Now, looking at this plot, you can see a couple of things. The top value here, the top blue circle, is pretty certain that that person has diabetes. Same goes for the person at the bottom. It's pretty certain that that person does not have diabetes. However, the two values in the middle are very close to this threshold. So maybe they're wrong, right? Because there's a lot of uncertainty around this. The top maybe has like a 53% certainty that the person has diabetes, and the other person has a little bit below this 50. Now, using the algorithm, we're gonna make predictions, and we're gonna the probabilities. And for the first row, we have a probability that a person has diabetes of 0.2, and the probability that a person does not have diabetes is 0.8. And that is this bottom blue circle here. Let me just point it out with a little laser pointer here that it's this one, right? Because the probability is very low that this person has diabetes. And also the prediction, the y-hat, predicted that this person does not have diabetes. So this is truly negative. And that's also what we're calling it true negative. Okay, so let's look at the other one, the second row. In this case, the person has diabetes, and the probability that the person has diabetes is 0.9. And indeed, it gets correctly classified as having diabetes. And this one here is the top value here, and indeed it is a person has diabetes. We call this a true positive. Now, here it becomes interesting, because if we're looking at the data, you can see that this person does not have diabetes, but the probability of him having diabetes is estimated at 0.6, and he gets wrongly predicted as having diabetes. And this is now a false positive. And the other one is the other way around. It gets falsely accused of not having diabetes while it actually has diabetes, and that is a false negative. So it gets falsely put into the negative bracket. Now, again, if we're putting this in a little table, let's do this right away. True positive, false positives, false negatives, and true negative. So top left, true positive, and bottom right, true negative. Now we can compute some metrics with this. Now 4 rows is a little bit, it's just not enough. So what we're going to do is we're going to add some data. And with this, with a magical touch, poof, we have more data. And now you can see that there's 126 true positives and 119 true negatives. And only a few false positives and false negatives. So, so it seems to be a very decent model. I'll color those to make it a little bit easier. Now, like I said, I can calculate metrics with this. So what I can do is I could calculate accuracy, which is the proportion of true results among the total number of cases. And I could calculate the precision. What proportion of predicted positives is truly positive? But let's stick with accuracy, right? So just the true results among the total number of results. I can calculate this. So let's do this. 126, you can see it top right here, 126 plus 119 divided by the total. And this brings me to a 0.897. So that's about a 90% accuracy. Now, when accuracy is not always useful. I'll give you the following example. What if I'm trying to predict a meteor crash in 1,000 days? So every time I sample, and most of the time, of course, there is no meteor crash, but just once there is a meteor crash. And when I now, train the algorithm, it will give me great results. It will give me a great accuracy, but it's not doing anything, right? Because I'm unable to predict this one-time meteor, but my accuracy will be awesome, because the total amount of true negatives is very high compared to the total amount of cases. So this is an example of where accuracy as a metric is not really useful. Now, that's classification, another form of supervised learning. And let's look at an example of unsupervised learning. Let's look at an example of clustering. And the example of unsupervised learning is that we do not have the outcome variable. We don't know. So in this case, in this example here for clustering, we're using flowers, and we have the length of the flower and we have the number of petals of the flower. Remember the example I gave you before we went to regression, right? Then we labeled the flowers, but now we don't have this labeling. So we're going to try to find clusters. How are we going to do this? Well, let's first put it on a two-dimensional plot. Now, on a horizontal axis and on a vertical axis, I'm going to place the length of the flower and the number of petals. Next up, I'm going to decide how many groups do I want to find. And I determine I want to find 3 groups, and that is called K. So I'm going to find 3 groups, and I'm going to place 3 data points randomly on this grid. And I'm going to call those centroids. And then I'm going to determine which are the nearest flowers of these centroids based on the mean distance. Let's make it a little bit more colorful, and here it is. So I found the nearest flowers. Next up, as this cluster algorithm is doing, is I'm going to place the centroids in the middle of the flowers it found. So here it is. Now it is nicely in the middle. And then again, I'm going to find the nearest flowers based on the mean distance. So let's see what happens now. Aha, okay. New thing. Again, placing the centroids in the center, and again, and again, and again. And this iterative process repeats itself until, it stabilizes. And let's show that. And here we go. Now we see we found 3 groups, and we adjusted the centroids based on the mean distance. Now, this clustering algorithm is called K-means clustering. And that is a simple example of clustering. And with that, let's go to our second lesson of this module. And in this lesson, we'll be talking about Azure machine learning. And what is Azure machine learning? And we'll look at the automated machine learning, and we'll look at the designer. But first, start at what is Azure machine learning? Well, simply said, it is a cloud-based platform for machine learning. And to use Azure machine learning, you'll need an Azure subscription. Otherwise, you won't be able to use anything. And in that subscription, you can create an Azure machine learning workspace. And a workspace is a logical container for resources you need to manage for your machine learning projects. And one of the most important resources here is compute. And remember when I talked about training times and that it would take forever on your laptop? Well, now you're in the cloud, so you can take this massive amount of compute and really, really, really reduce your computation times. But you need compute. The second one is also, pretty obvious. Well, you'll be needing data, right? You need to manage your data, and without data, you can't train your models. And another thing, which I think is absolutely fantastic, is experiments. So in the old days, and the data scientist would be behind his laptop and just trying out things, trying different algorithms, trying different features. Days go by, and at some point the data scientist realizes, 2 days ago I had the best result. Oh man, but what did I use again? Did I use this feature, or did I use that algorithm? Where's my documentation? Oh wait, I didn't write any documentation. Yeah. So now Azure Machine Learning tracks your experiments for you. So you can just easily go back in time and see when you got the best results or when you got completely different results. So that's a really great feature for Azure Machine Learning. Also, of course, when you have models, it stores the models. You can register and manage them completely in your workspace. And when you're ready to use your models in applications, you can publish them as services. And that can then be accessed over HTTP connections. So that is really a very short overview of Azure Machine Learning. Now, to give you another short overview, let's go to automated machine learning. Because automated machine learning is great. It takes a lot of hard work away from the data scientist. Normally you have to you tweak your features, you tweak your data, everything is ready, and then you're going to run the models. And then you're going to run a model. And then you're going to run the same model, but doing a little parameter a little bit different. And again, you have to wait. You're going to run the model again, doing a little bit differently. And again, you have to wait. So it's a very boring process, I would almost say. And why not automate this, right? Why not let Azure Machine Learning go through all these algorithms and all these different settings by itself? And then finally, it gives you the best model back. Now, that is automated machine learning. There's nothing to it. And I'll demo this later in the Azure Machine Learning Designer. But before that, let me just quickly tell you about what the Designer is. Because the Designer is it's a visual tool for creating machine learning pipelines. And a pipeline is basically a multi-step workflow to prepare data, train models, and perform model management tasks. As you can see here on the right side of the screen. On the left side here, you can see that these three main steps are important. You start with a pipeline that ingests data, pre-processes it, and then trains and evaluates the model. And then when you're happy with the results, you create an inference pipeline, which is based on your training pipeline. It will be a little bit different because this inference pipeline only needs to score. So it no longer needs, for instance, to split the data. And if you're happy with that, and the inference pipeline is ready, you can deploy it as a service that then client applications can use. On the right side here, you can see an example of a training pipeline. And note the following. First of all, we need data. So again, we have our diabetes data. Remember, in the classification example, we also had diabetes data, and now we have it again. And I have the data, but before I can use the data, I need to process it a bit. And in this case, I'm going to normalize the data. So what I want it to be, I want all the values to be a little bit on the same level. I'm going to normalize them and making all between 0 and 1. It's a very common pre-processing step for numeric features. After that, I split my data, and one part goes to the train model and the other part goes to the score model. The train model will train my data, and the algorithm that I'm going to use is a two-class logistic regression, which is a binary regression. It's going to predict either a 0 or a 1. After training has been done, my model gets scored, and then in the final module, I can evaluate my results. And I'll show you that later. So with that, let's go to the lab and I'll show you around. You can do this yourself. Go to aka.ms/nocodeautoml and just follow the instructions there. For now, I'll just create an Azure Machine Learning workspace, show you around in the compute targets. We're going to explore the data a little bit, train a machine learning model, look at automated machine learning, and then we're going to deploy the model as a service and even test it. Okay, so let's go. I've already put the link in a browser, so let me just switch to the browser here. And you can see here at the top of the screen, I already have entered here aka.ms/nocodeML. So let's run this, press enter, and it will open the learning path associated with it. Use automated machine learning in Azure Machine Learning. You can see that the third here is create an Azure Machine Learning workspace, and it will explain to you how to create a workspace, and the steps after it will ask you to go to the machine learning workspace itself and then open up the designer. But let's see first how to create a workspace. I need to go to the portal. I've already opened that in a separate tab here, and I can create a new machine learning workspace by actually multiple ways, but I could click here, I could type it at the top of the screen, I could click here and then add a new one, there are many options here. I can even, if at the flyout panel that gets here, I can even press create. It will open up a new window where I can create my machine learning workspace. I have to choose a subscription. I have to choose a resource group, because remember folks, we cannot create resources without a resource group. It needs a name, which is unique within the resource group. I'm going to give it AI fundamentals. Let's see if that's unique. It gives me a green tick, so that's unique. I'm going to provide it the region, and since I am from Netherlands, I'm going to say North Europe, and the workspace edition is Enterprise. Again, if you want to use Azure Machine Learning Studio, you will need to choose the Enterprise Workspace Edition. With that, I click Create and Review and Create, and it shows me some of the basics. I check it, everything is correct, and I can press the Create button. I'm not going to do this now because I've already created some workspaces. So let me just go back here, click the Home button, and if I click here on Machine Learning, it will show me my current Machine Learning workspaces. I see that I have 2 workspaces in different subscriptions right here, and let me just click the top one, the AI 900 AML. It brings me to this overview where I can see some of the settings where I chose the Enterprise Workspace Edition. The resource group is AI 900, the location is North Europe, etc. If I scroll down, I see, well, in a big font, Azure Machine Learning Studio, and I can open it up by clicking the Launch Now button. This actually will open up a new tab and starts loading Azure Machine Learning Studio. And here I can use the designer and use the automated machine learning features. It will first bring me to the home page where I can see some of my recent resources, and on the left I have all these settings. So let's go through them and let's start with the assets, and let's start with the bottom. If I want to do some data labeling, I can choose this option. If I want to connect data stores, right here I can have this option, so from external data source. And if I want to connect compute, I can click here. And here I have actually several options for compute. I have compute instances, I have compute clusters, inference clusters, and attached compute. Now, compute instances are really development workstations that data scientists can use to work with data and models. While compute clusters are really scalable clusters of virtual machines for on-demand processing of experimental code. Inference clusters are deployment targets for predictive services that use trained models, right? The ones that you trained. And attached compute is links to existing Azure compute resources, such as virtual machines or Azure Databricks. So that is compute. And we also have an option here, endpoints, but I will show you that actually a little bit more later, since we're going to train a model and then deploy the endpoint. Models, of course, since Azure Machine Learning, like it was in the slides as well, it stores my models and actually also keeps versions of it. I can easily track my pipelines that I created, and I can also track the experiments that I created. And as you can see here, there's currently one experiment, and it's called diabetes. Now, looking at data sets, I have added a data set. This is called diabetes, and if I click on the data set, it will give me some of the general properties, like the size of the data. Now, I'm not interested in the size of the data, I want to see the data. So here I can click Explore, and I can see the data there. It loads the data, gives me the first 50 rows, and gives me the columns. And I can see here, pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, etc. And on the most right, as you can see, the outcome variable, which is either a 1 or a 0. A person has diabetes or a person does not have diabetes. Now, it is interesting to see here, folks, because when you're thinking about data, you also have to think about, how to ingest the data, but also how to prepare the data. Sometimes the data is not ready yet. Maybe there are errors in the data. Maybe there is 66 typed out in letters instead of numbers, and it ruins the entire column, or there's a lot of missing data or weird values, and so you have to do a lot of data cleaning, a lot of preparation to make the data ready for the algorithm. Because remember, the model is only as good as the data it gets. Okay, and if I'm happy with this, I can use the data for my model. I could also, create other columns out of this, and this is called feature engineering. So maybe I could combine certain columns into a new column, or I think a great example here would be the date, which is not present in this column. But if I have the date, I could also create a new column with just the week number, or a new column with just the month number, or a new column with the season, right? And that is feature engineering. And then I can create lots of features, and then I have to select which features are important. But I'll show you that during the designer. Okay, and here we have the designer. Let me just click on this here. And if I go towards the designer, it will already give me some examples, which I can already use, build on. And below here, you can see the diabetes prediction. I've already started building this. It's a training pipeline, so let's click on this. I click on it, and it brings me to this new window. On the left, I can see all the modules that I can drag onto the screen. And here I can see the training pipeline that I've already made. Now, when I talked about feature selection, right, because you're going to create a lot of features, and sometimes you just have to select which one are important, there are modules for this. I could do this. I could click the feature selection, and I could drag one of these modules onto the screen and use it. Now, for now, that is not needed. So let's take a look at this training pipeline. It starts with diabetes data. I normalize the data, so I'm converting all the values to be between 0 and 1. So all the columns are a little bit like each other, and it's better for predictions. Next up, of course, right, we're going to split the data into training and validation, and the training set we're going to use a two-class logistic regression tool, which is a logistic regression, a binary classification. So it can classify into two classes, 1 or 0. And when that is done, I'm going to score the model, and I'm going to evaluate the model based on the results, right? I had the predicted values based on how I score the model, and I have, of course, the outcome values that I already had. Now, I can click on this as well. And remember, I can click on each module. So let me just show you that first. I can even click here on this two-class logistic regression, and it gives me some parameters that I can change. I'll get back to this, because if I want to change the parameter here, I have to train the pipeline again, and that will take time. And that is why automated ML, automated machine learning, is so great, because it does it for me, right? I don't have to do this all over and over and over again. Okay, so let's look at evaluate model. So it already ran, so it already did something for me. I made it quite basic. Let's look at some of the outputs. Evaluation results, and I click the third button here on visualize. We'll open a new window, and here I can see some of the metrics and some of the results. Now I'm not gonna go into these top 3, but I think you recognize this confusion matrix, which is the name of this 2x2 table. I can see that 71 cases here got correctly predicted as having diabetes, and I can see 220 cases of correctly not having diabetes. But still, there's plenty of false negatives, because they got predicted as not having diabetes while they actually had not had diabetes. And the same goes here, right? 27. Now, I already talked about the threshold, which we set at 0.5, but I can change this. And with that, also these accuracy and these other metrics change with it as well. Remember when we talked about accuracy and precision? Look what happens if I change the threshold. You can see now that the true positives go down, but the true negatives go up. And here also, there's also a shift here, right? 8 and 102. You can see that the accuracy changes as well. Now I can move it to the left, and you can see the opposite happening, right? The true negatives go down, but the true positives go up. And it's really dependent on the use case. And this is some homework I'm giving you. Think about, for instance, pregnancy tests. What is important there? I'm not going to spoil the answer for you folks. You'll have to find it out yourself. So that is really an easy way with the designer to create a machine learning model without using any code. I can just create this, run it, and I'm done. And when I'm happy with this, I can create an inference pipeline. For real-time inference pipeline, I can click this button, but it's grayed out. And it's actually quite simple why it's grayed out, because I've already created this. And because I created this, there is a button here that's now become available, real-time inference pipeline. I click on it, and now it opens this inference pipeline. It's a little bit different, because remember folks, I don't have to split the data, I just need to score the data. And I'm going to score the data using some web service input, and then I'm going to provide the outcome to a web service output. And I can publish this model, I already did, and now an endpoint becomes available. And I stalled it a bit, but here we go. Let's go to this endpoints part right here. Diabetes prediction. I'm going to click on it. I'm going to get some properties of this. I see the attributes, I see the REST endpoint, and I see how I can consume it using this tab. It also gives me some code, it gives me some keys, it gives me the REST endpoint. Really easy to use this. And even better, I can also just test it. If I click on test, I can see some of the values I can give it. I can change it if I want. So age 50, I can make it 77. And then I can press test right here, and it will give me an outcome. Also remember that the probability was always between 1 and 0, and that is also the case here. Scored probability is 0.7, which results in a scored label of 1. So it is predicted that this person would have diabetes. Now let's take a look at the automated machine learning, because I promised you that, so let's go there right now. I'm going to click here, and here it is. I'm going to click a new, I can create a new automated machine learning run by clicking the plus button. And here it is. It needs a data set, obviously. And I only have one, it's diabetes. I'm going to select it and I'm going to press next. Next up, it needs some other things. It needs an experiment name. And well, I'm actually going to choose an existing experiment because it's all for diabetes. And it needs a target column because it needs to know, what am I going to predict? And here it is. The bottom one is outcome. When I click it, it needs a compute cluster. I've already created that, so that's great. I don't have to do it. Click cluster 1, and there it is. I click next. And now it needs the type, right? It already found that it is a classification algorithm that is needed. So there's a green tick here. And I have some additional settings that I can choose from. So let's click on that. Additional configuration settings. Do I want my model to be explained? That's not needed for now. And do I need to block some algorithms? Because maybe I already know some algorithms that are going to work and some algorithms that are absolutely not going to work. So I'm just going to block them. And it also makes the training a little bit faster. I'm going to leave that for now. And I also have this featureization settings. And here I can see that, do I want to auto-detect the type? And maybe I can set it manual as well, that it's numeric, that it's text, or maybe even a date time. And if there's missing data, how do I want the data to be imputed? Do I just want to take the mean of the data, or do I want some other kind of option right here? But I'm going to leave everything at automated right now. And with that, I can press finish. And if I press finish, it will just start iterating through all these algorithms and just find the best model for me. Well, this can take several hours, so I'm not going to do this. I already had it run for 7 minutes, which is not a lot of time, but it finds some kind of model. And I can see it right here. On run 18, you can see here at the right, it ran for 7 minutes. So let's click on this one. And here I am. Properties, I canceled it after 7 minutes because I was done with it. I was like, okay, let me show me the results. And here on the right, it shows me the best model summary. It found out that the random forest gave an accuracy of 77%. And that was the best model. And I can view all other metrics, give me a complicated list of different metrics. well, not a complicated list, but a list of metrics. And I can just dive in there here. I can even see child runs, all the different runs that it did, some different output, etc. So without creating the pipeline, I just gave it the data, remember? I did some minor settings, and now I have here an algorithm that gives me a 77% accuracy without doing a lot of work. So hopefully that was a useful demo of the automated machine learning and the Azure Machine Learning Designer. Just to wrap up, in this module, we talked about the introduction of machine learning, and we talked about regression with a continuous outcome and numeric value, for instance, age. We talked about classification, really trying to classify something, having diabetes or not having diabetes, a 1 or a 0, a true or a false. And finally, we talked about clustering, right? Trying to find clusters in the data. After that, we talked about Azure Machine Learning. I showed you around, what is machine learning and that you needed a subscription for it, and that it is a logical container to keep all your resources in. I showed you around in the Designer, in Azure Machine Learning Studio, and the Designer, where we could drag and drop modules and easily create a training pipeline. And I showed you the automated machine learning. Without too much settings, I can just give it the data and let it run for itself, and then after some time, it will give me back the best performing algorithm. And with that, let's take a 10-minute break, and I see everyone back here in 10 minutes to begin module 3.